Excellent. We should be in our Unit 1 digital notebook on page 7, right? Page 7, where you see these beautiful highlighted rules. Today we're going to talk about the rules we use to determine the number of sig figs in a value. There are 5 rules. First one, any digit, any number that you see that's from 1 to 9 always counts as significant. So here's an example. We're determining the number of sig figs for each of these examples. In the box below that number 1, there's 1 digit, and it's not a 0, so there's 1 sig fig. Let's type that in. Yeah. Excellent question. To be a significant digit is one of the measurements that you can see on a measurement device. So what we learned yesterday about making sure that we measure all of the markings plus 1 estimated digit, those are our significant figures. Yes, sir. I did. Thank you for asking. Yeah. Avery helped me out. Ullrey helped me out. I need all the help I can get today. Appreciate it. 3.5 is our next example. There are 2 digits there, 3 and 5. Nothing, no zeros. So those are markings we can see. So that means we have 2 significant figures. That's in the wrong spot. Oh, lovely. 2. Everybody put 2 right there. 9.99. All 3 of those digits are from 1 to 9. So that would be 3 significant figures. We have a scientific notation number. This example is there on purpose. 1.34 times 10 to the 4. This part of this model of a number, we're not going to worry about when we count sig figs. We're only going to worry about the digits we see here, 1, 3, and 4. All of those digits are from 1 to 9, so we would call those 3 significant figures. So that's the first rule. Any digit that's not a 0 counts as a significant figure. Rule number 2, in orange, we have to determine zeros now. Those are the big questions. And there are zeros that are always going to show up out front, like these. Groups of zeros. Those are called leading zeros because they're in front. And they are never significant. Notice never is in bold and underlined. Never significant. So we don't count that 0. So how many sig figs do we have in this number? 2. The next number, 0.0023. Leading zeros don't count. So we have 2 again. This number, right? All these zeros out front don't count because they're leading. So we have 3 digits that do count. 3. And then that last number, all those zeros are leading. They're not significant. So we have 2 significant figures there, the 2 and the 1. All right. So far, pretty straightforward, right? It does get a little more complicated, so stay with me. Rule number 3, my favorite rule, because it's named after my favorite food, sandwiches. Don't look at me like that, Kaya. Sandwiches are the best. Sandwich zeros are the best. They are significant, right? And a sandwich 0 is a 0 that's stuck in between digits that aren't 0. So see these zeros in the number 2001? They're sandwiched in there. That means they are significant. So the 2 and the 1 definitely count because they follow rule 1, right? These zeros, though, stuck in the middle, are significant. So here we have 4 significant figures. So we've got to be careful with our zeros. Here's another number, 1.0101. All the 1s count. Now we need to think about the zeros. Do they count? They're sandwiched. Trey's shaking his head, yeah. So we have to count those as significant figures. Those are measurements that are significant. So 5 sig figs there. The next number, got a lot of zeros in there, but they're sandwiched, so we do count them. That is 8 total. So the 1, the 8, and the 9, and then 5 zeros. They all count. And then the last number, another scientific notation number. Remember, we don't think about times 10 to the 5 when we're counting sig figs. But we have sandwich zeros. So there are 4 significant figures there. The 1 and the 2 count. And then those 2. Zeros are sandwiched, so they do count. Cool. Let's move on to the next rule. Rule number 4. This is where it gets tricky. Rule number 4 says trailing zeros. Trailing means at the end of the number. They are only significant if you see a decimal point. Okay? Only significant if you see a decimal point. So we've got this number 10,000. There's no decimal point. So the zeros at the end are not significant. So that means only the 1 is significant. So there's 1 significant. If we take the same number and tack on 0.0, these are trailing zeros, and that decimal point makes all of those zeros count as significant figures. So we've got to count 1, 2, 3, 4, 5, 6. That decimal point changed the number of significant figures. 50 point, right? It's a little weird to see that, but there's a decimal point, so that makes our 1 trailing zero significant. So here we have 2 sig figs. And then we have another scientific notation number, 4.0000 times 10 to the negative 2. Remember, we're not going to worry about this part. I'm not going to say ignore it because we're not going to ignore it. It's important. But when counting sig figs, we only look at the number in front of the times 10. There's a decimal point. That makes all the trailing zeros significant. So that would be 5 sig figs. So to recap about zeros, it's the hardest part, zeros. Leading zeros, don't count. Doesn't matter. If they're out in front, don't count. Sandwich zeros, always count them because sandwiches are the best. Trailing zeros, we only count if we see a decimal anywhere in the number. Okay? It has to physically be there. We have to see it. Okay? Rule number 5, it's kind of a standalone, but it's important. Exact numbers that we get by counting something, or when we're using exact values from conversion factors, have an unlimited number of significant figures. So here's a number, 30 students. We counted everybody in B hour. That'd be an exact number, right? We have 30 students, not 31, not 29, not 29 and a half. 30 exactly. So we have unlimited significant figures. And I abbreviated that word. Here's a conversion factor. 1 minute equals 60 seconds. That's exact. We know that. It's exactly 60 seconds. So we have unlimited significant figures. $1 equals 100 pennies. We know that for sure. There's not a fraction of a penny in there. So its exact numbers, unlimited significant figures. Those are the 5 rules. Number 1 and number 5 are pretty easy. Non-zero digits count. Exact numbers, unlimited. The zeros is where we get in trouble. Leading, never count. Sandwich, always count. Trailing, only count when we see a decimal. Let's look at some examples. Those of you at home, be ready to be called on. 36,000. We've got some zeros in there. We know the 3 and the 6 count. These zeros are trailing zeros, and the rule says it only counts if we see a decimal, and I do not see one, so I don't count them. I have 2 significant figures. 9.100 times 10 to the 14. The 9 and 1 totally count. The zeros are the question. Trailing again. But I have a decimal. So now I have to count them. That's 4 significant figures. 12 cats. There are 12 cats somewhere. Right? Maybe at the animal shelter is the place where you would likely find 12 cats. That's an exact number, right? So we would call that an unlimited number of significant figures. The next number is a little tricky because we see 2 different kinds of zeros. The 4 and the 1 definitely count. There's no question there. What we've got to think about are these zeros out front. Those are leading. They never count. Even if there's a decimal. Never count. And then this zero here is a sandwich zero. And the rule says those always count. So here we have 3 significant figures. And the next one is tricky as well. Let's take a look. The 2, the 4, and the 2 are significant. No question there. We have some sandwich zeros, right? This first one is sandwich, and so is the second. Those definitely count. And then we have 1 trailing zero. And the rule says trailing zeros only count if we see a decimal. I definitely see one. So this 0 does count. So that is 6 significant figures. Let's do example number 2. Trey, number 768. How many sig figs? 3. You got it. That one's easy. There's no zeros, so we count all the digits. Let's see. At home, let's go with Ethan Vega. Can you unmute yourself and tell me this second one in example 2? How many significant figures do we have?
4.
4. Okay. The 3 and the 5 definitely count. Where did you get the other 2 from? Tell me about it.
Oh wait, they're leading zeros or
They
whatever.
are,
So
yeah. So it's just 2. Excellent. Good way to revise your answer. Leading zeros, even if there's a decimal, don't count. 2. Cool. Thank you, Ethan. Let's go with Layla. Can you unmute yourself and tell me how many significant figures you see in this number? Layla Padmore. Okay, not getting an answer there. Let's move on to someone else. Savannah Harrison, can you unmute yourself and tell us how many significant figures you see in this number?
7.
7. Why do you know that all those zeros do count?
Because it's sandwiched between 2 numbers that aren't 0.
Right, exactly. The 2 numbers, 1 and 3, sandwich all these zeros. So we have to count them. So there's 7. I don't need to write that because it's going to be on the screen. 7. Excellent. In class, Abigail, 4.20 times 10 to the negative 5. How many significant figures do you see? 3. How do you know that that 0 counts? Because of the decimal. Excellent. The decimal definitely makes that trailing 0 count. So 3 sig figs. And then the last one, 12 eggs. Kaya, how many significant figures? Unlimited. That's an exact number, right? That's a dozen eggs. Like when you go shopping in the store and buy eggs, they usually come in a dozen. Exact, so we would say unlimited. Good work, ladies and gentlemen. What questions do you have so far, either in class or at home? Okay, let's keep moving on, friends. Example 3, I want you to try on your own if you haven't done so already. There's a 2-minute timer. I don't think I'll let it run out. Try number 3 on your own. Is that you done? Excellent. Have you done? You still working on it? Okay. Okay, cool. What did you say? I was asking you. You are. Avery, good to go? Cool. All right, ladies and gentlemen, looks like everybody has had a chance to answer those, so let's go over the solutions. 50,000, someone from home, let's go with Ethan Leach. Ethan Leach, please unmute yourself and tell me how many significant figures are in the number 50,000.
I got 5.
5, okay. So the 5 definitely counts as one significant figure. Why do these zeros count?
Because it's a comma, not a decimal. So
Okay.
it's
Do we have a rule? Do we have a rule about commas? No, we don't. Right. The rule is about a decimal. We don't see a decimal, so these trailing zeros do not count. And Ethan, that's an okay mistake to make. Thank you for making it. That was a learning opportunity for everyone in class. One significant figure there. Lauren, this next number, how many sig figs do we have? Okay, that's a tricky one. The 3 counts. Tell me what other digits count. Why do these zeros count when all the ones out front do not? Because there's a decimal, right? The decimal makes the trailing zeros count. But it doesn't matter about these leading zeros. They never count. Good job. Let's get someone at home. Morgan, Please unmute yourself and tell me how many significant figures are in 500.02. Morgan Navalta. All right, not getting an answer there. Kelsey Reyes, you're up, 500.02. How many significant figures?
5.
5. Tell me about those zeros. Why do they count? Kelsey, can you tell me about the zeros?
They count because some of them are sandwiched and the trailing one has a decimal.
You're right. So we would still call this one a sandwich zero. All 3 of those are sandwich. But good work, Kelsey. Good job. That's excellent. 500 points. Trey? 3. Why do they count? What are the zeros? And that decimal makes them count. You got it, sir. Good answer. And then we have 1 centimeter equals 100 millimeters. Let's go with Mariah. It's Mariah. Yeah, it's here. So unmute yourself, Mariah, and tell me how many significant figures there. And ignore the wrong number. It should be 10 millimeters. Mariah.
Would it just be 2?
Nope. This is an exact value. So let's look at rule of
unlimited then?
There you go. Excellent answer. Thank you, Mariah. Unlimited. So we will put UNLTD there. Boom. Okay. Excellent work, ladies and gentlemen. Sig figs aren't too bad. They're a little weird to get used to, but we're going to keep rolling with this, and you'll get really good at it. Let's talk about rounding. I'm going to review the rounding rules that you learned a long time ago and hopefully remember. So we're going to round to the correct number of significant figures. Rounding rules. First, we got to figure out what number we're rounding to, and we locate that digit. Number 2, we're going to look to the right of that rounding number. If our number is to the right, it's between 0 and 4, we don't change the rounding number. If it's 5 and above, we do change the rounding number. And then if there are any digits after the rounding number, we need to change them to 0. So here's an example. We want to round this number, 34,678, to 2 significant figures. So we find the second digit. It's the 4. Right? So that's our rounding number. We need to keep those 2. We look to the right of the 4. There's a 6. Right? So that means round the 4 up. So the 4 becomes a 5. So we keep the 3, change the 4 to a 5, and then every digit after that we have to change to zeros. We've got to remember that step. Those have to become zeros when we round this, because when we round, the number has to be close in value to the original value, or the original number. 35,000 is really close to 34,678, right? A lot of times we see people round this number as 35. They follow all those steps except this last one. 35 is so small compared to 34,000, right? So make sure we keep those places by changing these digits to 0. Okay? Cool. So let's see some examples. We've got a number here, 21.998. And I need to round that to 4, 3, 2, and 1 significant figures each. So 21.998. To round to 4 sig figs, I go and find the 4th digit. I have to keep everything in front of it. Which is that 9 right there. 1 times of the ring. And we're going to look to the right of that 9. And there's an 8. 8 tells us to round our rounding digit up, right? So 9 rounds to 10, which we can't write 10 there. So it means we need to look at 99. 99 rounds up to 100. We can't write 100 there. So we look at 1.99. That can round up to 2.00. So this number becomes 22.00. That is 4 significant figures. Those trailing zeros count because of the decimal. Right. Now we need to do the same thing, but for 3 significant figures. So we look at our 3rd digit, which is that first 9 right there. We look to the right, 9 says round up. Can't 9 round to 10, so we round 1.9 to 2.0. Right, so this becomes 22.0. Two significant figures is our next step. So we find the second digit, which is the 1 this time. We look to the right, there's a 9, that means round 1 up. Round 1 rounds up to 2, so this number becomes 22. And then one significant figure. The first digit is 2. We look to the right of it, and there's a 1, that means don't round it up. Right? So we don't round up the 2. But each number going past that, we need to make sure we change to 0. So that 1, we're going to change to a 0. 20 has one significant figure and is really close to 21.99. So we got to make sure that 1 becomes a 0. That's super important. That's the biggest mistake we see with rounding. Let's look at example number 2. This number is 44,000. We follow those same rules to round this number. 44,000. Let's look for 4 sig figs. We got to go to that 4th digit over there, which is a 0. We look to the right of it. There's another 0, so we're not going to round up. But if I just write all this without a 0, that doesn't help. That's 4,400, nowhere near 44,000. So when we have a large number like this, what we have to do is put it into scientific notation. So I need to move my decimal, which isn't there, 1, 2, 3, 4 places, and this becomes 4.000 times 10 to the 4. Now this number is what I'm going to round. I'm going to go to my 4th digit. I left off a 0, sorry guys. No, I left off a 4, that's what it is. I go to my 4th digit, which is right there. I'm not going to round it up. So I get 4.400 times 10 to the 4. Yeah. To write that, you hit Control, period. And that'll bump your cursor up to the superscript position, and you type it. To undo that, you hit Control, period again. Good question, Zach, thank you. No one AR asked that. Bummer. Let's do the same thing, but with 3 significant figures. So I'm going to take my scientific notation number, and I'm going to find the 3rd digit, which is this 0. Look to the right, I got another 0, so I'm not going to change anything. This becomes 4.40 times 10 to the 4th power. Two significant figures, following the same steps here. Find my 2nd digit, which is this 4. Cut off everything after it, because 0 is not going to make that round up. Trey?
I just have a question.
Sure.
You still have to use the scientific notation of 44,000.
That is a great question. I was going to go over that when I finished this example. But we can write 4.4 times 10 to the 4. And Trey brings up a great example. Look, this number, as it sits, is already 2 sig figs. So you could also write 44,000 without a decimal, and it would work. Both of those answers are acceptable. And we're going to say the same thing with 1 significant figure. So when I look at 1 sig fig, that's the 1st digit. There's a 4 to the right of it. I'm not going to round up. So this could be 4 times 10 to the 4. Like that. Or I could write 40,000, right? 40,000. Would be 1 sig fig and it is close to 44,000. Good insight. Thank you. Okay. I want you to take... Oh, Zach, go ahead. Question. I can't hear. Charge? There's actually an extension cord behind Lauren. Sorry, I had to make sure I didn't call you your sister's name. If you can pull that forward and then string your cord back that way, you can plug it in there. Thanks for asking, Zach. I want you to try example number 3 on your own. The number is 0.7541. Zakiah, does this 0 count as a significant figure? Y. Say loud. You were right the first time. It does not count because it's leading, and they never count. Okay. So keep that in mind when you round this number. Go ahead and take a couple seconds to give that a try, ladies and gentlemen. Try all 4 of them, and then we'll go over the solutions. At home, when you get done with those, if you can put a W in the chat, let me know how we're doing on time. Example number 3. You good, Zach? You got it? Okay. Remember, at home, I'm looking for a W. Okay, I got a couple W's in. There's 14 of you at home. I should hopefully see 14 W's coming. Ethan, we'll have to talk about that at a later date. I'm currently recording myself, so I'm not going to put that out there forever. All right, let's go ahead and get started. Janaya, you're here in front of us. Can you tell me how to round this number to 4 sig figs? Okay. I talked about this with Zakaya. Does this leading 0 count as significant? No. Right? So we need to find the 4th digit that is significant, which is that 1. Right? And there's nothing behind it, is there? So if we round this number to 4 sig figs, it is literally the same value. Right? So we have nothing to round. Okay. That was a little confusing, I agree. 0.7541. Now, let's do this to 3 sig figs. Avery, what's the 3rd digit that is significant? 4. We're going to cut it off right there. Does the 1 make the 4 round up? Nope. So we get 0.754. Excellent. At home, Jason Miggins, can you unmute yourself and tell me how to round this number to 2 significant figures? Jason? Okay, not getting an answer there. We're going to go with Allison Reynolds. Can you unmute yourself and tell me what this number is rounded to 2 significant figures? Okay. Not getting an answer from Allison. Let's go with Areli. Can you unmute yourself, please, and tell me what this number is rounded to 2 significant figures?
Would it be 0.75?
You got it. Thank you so much, Aurelie. 0.75, right? The second digit is 5. The second significant digit, is 5. 4 does not make it round up. Let's go with Ariel in class here in front of us. To 1 significant figure, what do we get?
I put 0.8.
Yeah, tell me why you rounded 7 to 8. 7 is the first significant digit. To the right is a 5. It makes it round up. Exactly, 0.8. Good work, everybody. Right here, I need you to take a quick 2 minutes, write down a list of steps that you would use to round this number 3.1477 to 2 significant figures. So you're writing out statements. They don't have to be sentences. They don't have to be grammatically correct. Just steps, okay? Step 1, do this. Step 2, do this. So on and so forth. Give it a shot. You should. You guys. Cool. We need to stop. Should we stop? Practice today.
I think we should try and fix that today. Because it would be very common for graded it needs another place to
Maybe we can just use the links. Links here. That's okay. We can handle it. All right, here we go. Our 2 minutes are done. Let's talk about this. How would we round this number to 2 significant figures? Zakai, what are we going to do first? Second digit, not just the second digit, but the second significant digit, right? That's one key piece of information. Find the second significant digit, which in this case is the 1, right? What are we going to do next, Trey? So round that number to 2 sig figs.
Oh. And then, I just said look to the right.
Cool. Look to the right. Are we going to round up or keep it the same, Trey? Right. We're going to keep 1 because 4 doesn't. Does that make sense if I say it that way, everybody? We're going to keep the 1 because 4 doesn't round up. Zach, what's next? $31. Is that close to 314.77? Two. You could change it to scientific notation. That is completely acceptable. Or we could just zero. Right? We're going to replace 4 with 0 to keep the value close. So if you change it to scientific notation, 3.1 times 10 to the 2, totally awesome. Keep that. Don't change it. But you could also do it this way. All right, friends. The next part of your digital notebook is practice. I'm going to go ahead and start this music and this timer. And I would like you to practice converting these numbers. The bell's going to ring before we're done. That doesn't mean we're done now, because in this class we work bell to bell. So make sure you are working until the bell rings, and I dismiss you. Let's try rounding some numbers based on significant figures. If you have questions, feel free to put them in the chat. All right, let's make some work happen, guys.